Have you ever dreamt of hopping into a time machine and journeying to the past, or perhaps the future? If so, you're not alone. Time travel, a concept that has captured the human imagination for as long as we've been able to conceive of time itself. It's been the driving force behind countless blockbuster films, novels, and even the occasional daydream. It's a tantalizing thought, isn't it? The ability to revisit the past to see the future unfold before it happens. The allure of time travel is undeniable, sparking intrigue and wonder in our minds. It's a universal fascination, transcending borders and cultures, a testament to our innate curiosity and desire for exploration. But here's the question that lingers in the shadows of our fantasies, the one that keeps us grounded in the present. Yet, why is it that we don't see time machines parked in our driveways? Why does this concept remain a dream? The answer lies in the laws of physics, our current understanding of how the universe works. At the heart of our understanding is Einstein's theory of relativity, a cornerstone of modern physics. This theory, in its broad strokes, tells us that time and space are interconnected in an intricate tapestry we call space-time. Now, this is where it gets interesting. According to relativity, if we could travel close to the speed of light, we might be able to manipulate time. However, such a journey would come with some rather severe side effects. Consider this: as you approach the speed of light, time begins to dilate or stretch. This means that while you might feel like you've only been traveling for a few minutes, years, even decades could pass by on Earth. It's a bit like the most extreme jet lag you could ever imagine, and that's not all. There's also the small matter of your body getting squished or experiencing extreme gravitational forces as you reach these astronomical speeds. Not exactly a leisurely trip to the past or future, but what about shortcuts, you ask? Here's where black holes and wormholes come into play. These cosmic phenomena are theoretically capable of bending space-time, creating a sort of tunnel that could potentially allow for quicker travel through time and space. Sounds great, right? Well, there's a catch. These shortcuts are incredibly unstable, and any attempt to traverse them could result in catastrophic outcomes. They're more like cosmic death traps than convenient time portals. So, while our imaginations can run wild with the idea of hopping into a time machine and zipping off to another era, our current understanding of physics seems to have other plans. It's almost as if the universe has set up these natural laws as a sort of cosmic speed bump, slowing us down and reminding us that, at least for now, time travel remains within the realm of science fiction. So our current understanding of physics puts a damper on our time travel dreams. And then there's the grandfather paradox. This is a conundrum that really puts the tangle in the time travel spaghetti. Imagine, if you will, that you've managed to build a working time machine and you decide to travel back in time. You're wandering around in the past, perhaps enjoying a spot of tea with your grandfather in his youth, but oops, you accidentally prevent your grandparents from meeting each other. Now this is where things get really tricky. If your grandparents never meet, they never have your parent, which means you are never born. But if you were never born, then who traveled back in time to prevent your grandparents from meeting? It's a real head-scratcher, isn't it? This is the essence of the grandfather paradox. It illustrates the chaos and confusion that could result from altering the past. The concept of cause and effect, which we rely on to make sense of our world, gets completely thrown out the window. In a universe where time travel is possible, the effects of our actions could precede their causes. This would twist our understanding of reality into a pretzel, and not the tasty kind. The paradox suggests that even if time travel were physically possible, it could be inherently paradoxical and thus logically impossible. It's a bit like trying to square a circle or divide by zero. It's also worth noting that some physicists suggest the paradox could be resolved by the many worlds interpretation of quantum mechanics, where every possible outcome of an event happens in a separate universe. But that's a topic for another day. In the end, the grandfather paradox serves as a stark reminder of the potential pitfalls of messing with the timeline. It suggests that the past may be a dangerous place to visit, filled with potential paradoxes that could unravel the very fabric of existence. Our universe might not be as welcoming to time tourists as we'd like. What about traveling to the future, you might ask? Well, that's a slightly different kettle of fish. The theory of special relativity tells us that time runs slower for objects moving at high speeds. Imagine an astronaut on a spaceship traveling near the speed of light. When they return to Earth, they could find themselves in a future far ahead of when they left. This is known as time dilation, and it's a fascinating concept. So in theory, this could be our ticket to the future, and it's a big but, there are some rather significant hurdles to overcome. Firstly, we don't have spaceships that can travel anywhere near the speed of light. The fastest spacecraft ever launched by humans, the Parker Solar Probe, travels at around 430,000 miles per hour. That sounds fast, and it is. But it's still nowhere near the 670 million miles per hour that is the speed of light. Then there's the issue of energy. To propel a spaceship to such incredible speeds would require an astronomical amount of energy, the kind of energy we simply don't have access to with our current technology. Even if we could generate such energy, there's the question of how to store and use it effectively. And let's not forget the physical toll such a journey would take on the human body. At near light speeds, the forces involved would be immense. Without some form of advanced protection or life support, our astronaut might not survive the trip. So while the theory of time dilation suggests that travel to the future might be slightly more plausible than travel to the past, it's clear that we're still a long way off. The technology and energy required for such a journey are beyond our current capabilities. We're still stuck in first gear, so to speak. Although future travel seems more plausible, we're still far from making it a reality. So for now, time travel remains a captivating concept, a tantalizing possibility that fuels our imagination and our desire to explore the unknown. Despite these hurdles, why is the idea of time travel so captivating, you may wonder? Well, the answer lies within the very fabric of our human nature. We are creatures of curiosity, always longing to explore the unknown, conquer the uncharted, and unravel the mysteries of our existence. Time travel tantalizes this innate desire, offering the possibility to rewrite history or dare to peek into the labyrinth of the future. This fascination is more than just a whimsical daydream. It fuels the engine of scientific inquiry, pushing us to challenge the boundaries of our understanding. Even though our current theories might not support the notion of practical time machines, the allure of time travel continues to inspire scientists to think outside the box, to question the status quo, and to delve deeper into the enigmatic workings of our universe. The idea of time travel, while currently unattainable, drives us to push the boundaries of our understanding. So, where does this leave us? In the realm of scientific discovery, the potential for breakthroughs is always on the horizon. As we continue to delve into the mysteries of the universe, who's to say what astounding revelations we might unearth? Indeed, the core of science is about evolution, about continually challenging and refining our understanding of the world we inhabit. It's about keeping an open mind, always ready to embrace new concepts and possibilities. Though time travel remains in the pages of science fiction for now, the future is a canvas of infinite potential. It's a realm of what-ifs and maybes, a space where the impossible could become the probable. While we may not be hopping into a time machine anytime soon, who knows what the future holds?